Welcome to Spring LIB.
Okay, so we've got a regression model, sample size n equals 25. Not really super important. The important thing is that our Durbin Watson statistic is equal to 0.81, right? And we're using an alpha of 0.05, and what we're trying to say is that based on this information, what can we conclude? And what we're really focusing here is on the Durbin Watson statistic. This is not super important, and neither is this, right? So what is the Durbin Watson statistic? It's a test for autocorrelation within a regression, right? So when we do regression, if the very fact of the matter of the thing we're measuring influences that thing in the future, then we've got autocorrelation, right? Whether that's positive or negative autocorrelation. So if a stock price, consider we've got a stock price, right? And we know if it was high today, if that means it's more likely that it's going to be high tomorrow, then that's a positive correlation, positive autocorrelation. If being high today means that it's most likely to be low tomorrow, that's a negative autocorrelation. Right? And that's what we're testing for with Durbin Watson. Is the price today influenced by the price yesterday? And if so, is it positively correlated or is it negatively correlated? Right? So the Durbin Watson statistic can range from 0 to 4. Okay? If the Durbin Watson is below 2, right? That implies a positive autocorrelation. If the Durbin Watson is greater than or equal to 2, that implies a negative autocorrelation. Okay? But if the Durbin Watson is 2, that implies that there is no autocorrelation. Right? So you can kind of think of it as a spectrum: positive autocorrelation over here at 0, negative autocorrelation here at 4, and 2 is in the middle. No AC, right? It's a spectrum from 0 to 4 where 2 is in the middle. And our Durbin Watson statistic was 0.81. That's what our DW equaled, okay? So what does that look like? It means, well, to me, it looks like we have positive autocorrelation. We have a positive autocorrelation. I did not spell autocorrelation right. There we are. Okay. So what are our options? A, the residuals are not normally distributed. That's not implied by this. The residuals are negatively autocorrelated. That's the opposite of what we just found, right? The residuals are positively autocorrelated, right? Yeah. So C.